Hi, thanks for joining us. I'm Pete Zielinski. I'm editor-in-chief of Additive Manufacturing Media, and the webinar you're about to see is about the connection between metal additive manufacturing and environmental impact, metal additive manufacturing and sustainability. Part of the promise of additive manufacturing is more energy and resource efficient manufacturing in lots of ways. Lighter weight components with less material use and even with a lot less transport cost because of the way additive manufacturing enables production as needed near the point of use. But what's the environmental impact of the entire process for making a metal part additively? Starting with material production. This presentation is brought to you by 6KAdditive, a powder material provider with a production process that is particularly well suited to reclaiming and recycling metal. 6K recently commissioned an independent life cycle analysis to measure the energy, carbon, environmental impacts of its metal powder production process. So in this webinar from 6K, we'll hear from 6Kadditive's president, Frank Roberts, and we'll also hear from Brad Van Valkenburg, who is sustainability manager for Foresight Management, which is the firm that conducted the life cycle assessment. How do we think about the full impact of manufacturing choices and where the environmental costs occur? This webinar will get into that. As Frank and Brad are speaking, please feel free to ask your questions. You can do that using the Q&A section at the right of your screen. We'll see the questions entered in that box, and at the end of the presentation, we'll answer as many of them as we can. So I'm going to cut out briefly. I will be back, but Brad, I think we'll start with you. If you're ready, please take it.
Great. Thank you, Peter. As mentioned, my name is Brad Van Valkenburg. I'm a sustainability manager at Foresight Management, the company who conducted the independent LCA, and I was the LCA practitioner on this project. My main focus at Foresight is to do a lot of product analysis, so help our clients understand what is in their products. So that can include the chemicals, trying to get down to their product chemistry of identifying any toxic chemicals, and then on the other side, I'm the LCA practitioner here to help our clients better understand the environmental impacts of their products, where things are, what is adding to their embodied carbon, embodied energy, help them identify and create better products. A little background on Foresight Management. We are an energy and sustainability consulting company where we look to champion energy management, accelerate sustainability, and increase profitability for our clients. At a very high level, we're here to help our clients collect, analyze, distill, and understand any and all data related to their ESG. ESG is a growing topic in the marketplace right now. It's everywhere you look, you see people asking for ESG data, and we want to help our clients answer those questions and understand why this is all important. We work with a large handful of companies across various industries. We're not locked into one. We do a lot of work with office furniture manufacturing, auto part manufacturing, tier 1, tier 2 suppliers, some of the big OEMs, and now working with some metal additive manufacturing. So we're not locked into a specific industry. If anyone has questions or wants to understand their sustainability story and journey, we're here to help, and we want to help. So how do we do that? Our generic process is we first want to see what you have. We're going to measure what you're doing, measure your baseline. From there, we'll identify any possible improvements, help you design those improvements, implement them, measure the results of those, and then it's just a nonstop circle, a flywheel, as we call it here, of improvement. We always say sustainability is not, sustainability is a journey. It's not just a one-off thing. So we really want to encourage our clients to work with us and work with them through this flywheel and help them through their entire sustainability journey. Like I said, ESG covers all facets of manufacturing. It can look at the high-level organizational, the buildings, and the products, and we help our clients with all of that. Today, obviously, we'll be focusing on the product side because we actually did an LCA, which is purely down to the product level of the environmental impacts of those products. So some of you may not be aware of what an LCA actually is. So what is an LCA? Well, an LCA is a systematic way to study and analyze your products, and it gives you the environmental impacts associated with that. And that will look at the entire life of your product, from raw material manufacturing to what happens to it when it's done. We call this in the LCA world a cradle to grave scope. And additionally, it lets you look at where are these hotbed areas in your process. Is there a specific material that uses more energy or has a higher bodied carbon than another material? Is there a single process that uses more energy? What if 80% of your embodied carbon comes from a single process? And LCA will let you identify that and start to study and see what can we do to lower that amount. Outside of the actual work, there are frameworks around here to help all of these LCAs be done in a similar manner with the same way that materials are treated. These frameworks are lined out in ISO 1440 and ISO 1444. As I mentioned before, this is the entire life of the product. So it goes from raw material manufacturing. So it goes from, in this case, actually mining the metals that go into these powders, pulls into the refining, into the processing of those, and then it comes to your gate, which in this term is called gate to gate. The initial raw material is cradle to gate, and then once it's to yours, what energy are you adding to that raw material? What are you doing to it to make it your product in that gate to gate boundary? And then after that, obviously it goes to, if you're the last gate in that manufacturing process, it goes to the user, and then we want to quantify, is there anything else that needs to be done to it? Like if you're looking for a TV, that TV uses electricity. How do we quantify the energy used from that product during its entire lifespan? If we're looking at LCA for a car, cars require gas, cars require oil, they require new parts. All of that is built into that use phase. So this use phase can get incredibly complex when included in these LCAs, but it's important to understand what additional things need to go into the product throughout its lifespan. And then once we're done using it, we have to deal with it at the end of its life. So this could be landfilling the product, it could be incinerating the product, this could be recycling the product. Can you disassemble the product into different materials and recycle some and not others? And that's all these are all small little caveats and between the different stages of an LCA from cradle to grave. Additionally, in between all of these stages, we have to ship these products. This transportation, all these transportation methods are also included in the LCA as well. But why would you want to do an LCA? An LCA is a great way to actually look at the carbon impact of your product, as well as energy usage. But what does that number even mean sometimes? So a lot of times we're seeing people come to us asking for this because they're receiving market pressure. There's a lot of clients who are putting in carbon pledges if they want to be carbon neutral by 2050 or 2040. And part of that is understanding the carbon going into their products. So if you're supplying a part to a customer, they may be asking, what's the embodied carbon of this product? And an LCA is a way for you to answer that. Additionally, if you're client facing, a lot of people are looking for product transparency right now. And part of that includes what is the energy, what are the environmental impacts of this product? So we are starting to see some more larger organizations actually start putting this into their buying process. Large companies may when they look at buying new office furniture, may look at what's the embodied energy and embodied carbon of these, and actually put a weight to that in their decision making. So if you don't have that number, sometimes you can be left out of bids because of that. Additionally, there are some certifications that you can get from that require you to do an LCA and actually provide the environmental impacts. A lot of this comes along the lines of product category rules, which are similar in a way to the ISO 1440 standards for LCAs, where it tries to align all the products in a single category into one normalized kind of space. So it's easier to compare one office chair to another. In this case, the office furniture industry has a lot of PCRs. So they're trying to normalize all these different products from all these different manufacturers and actually let people compare embodied carbon from one product to the other. You may want to use these LCAs to actually tell your story. Everyone's doing some sort of work in the sustainability world of trying to make their processes better, trying to use less energy. And an LCA can help you tell that story. I always say an LCA is a way to quantify what's in your product when it comes to carbon and energy. And if you can actually show that and have a number, you can say, hey, what we're doing has resulted in this much less carbon that goes into our products. This is why 6K approached us. They have this new technology they wanted to show and want to say, we know this is better than what's happening right now. Can you help us prove it? So we've conducted this LCA to provide them the impacts of their new process. And then those are all external factors. On an internal level, LCAs are a great way to actually design your product. You can put this into your design for environment framework, where part of your decision making of whether or not you replace a part or change a material, maybe change a supplier, is based on the environmental impacts of those. And an LCA is a way for you to actually look at the impact changes of changing. Maybe you're changing this one plastic in your piece to an ocean-bound plastic, right? You're no longer using a virgin plastic resin, and you're recycling ocean-bound plastic into your product. What does that look like? Not only from a logistics level, but now you have an actual carbon equivalent difference between virgin to recycled. Additionally, what if you're changing suppliers or consolidating everything into one building? You're changing your transportation back and forth. So that has a impact reduction. This allows you to actually see what that direct reduction might be. Once you have these LCAs done for whatever reason you're looking for one, some direct applications you can use would be product development, using information in the strategic planning side, as well as making some public policy changes, and then as well as mentioned before, marketing to help tell your sustainability story. But how exactly do we do this? Oh yes, thank you. We want to drop quick poll question, just kind of, do you have any current sustainability metrics in your company? And if so, could an LCA help with some of that? So if you could please answer that poll question, that'd be great. Thank you. Also, how do we actually do an LCA? So the first part of an LCA process is you want to define the scope and goal of the LCA, right? Why do you want to do an LCA? We always tell people who approach us who want an LCA, we'll do one for you, but why do you want to do one? We're happy to help you with it, but unless we know why you want to do it, it's tough for us to really provide the support and data you need to actually use in whatever form you want. So whether it's an EPD, whether it's you're looking for design side, you're looking for a marketing, we want to know why you want to do it, and then also what are we doing it on? So the scope of it, and these work hand in hand. In this case, for 6K, the scope and goal was to help quantify their new process compared to traditional processes. And in this case, we chose to do it from a cradle to end user scope, because the way we're looking at it as it left the facility, it's all the same material. So therefore, the use and end of life would be identical between each different model we ran. So for this case, we decided to lock it down to a specific scope for a specific functional unit of printable powder. Once we have an understanding of what we're doing the LCA on, why we're doing it, and we know the boundary of it, which in a lot of LCA language is called the technosphere of all the technology that is being studied in this case. Then we can start identifying all the different processes that go into that technosphere, right? So if we look at the entire model that we're looking at as a box, we have a bunch of sub boxes inside of it, and those boxes have more boxes inside of it, and it's just, we can go as deep as we want on these, but we have to, at every step of we have a new box, identify inputs and outputs. we understand that at some point of this life cycle, we can't get primary data for inputs and outputs. And that's where we can start using LCI databases to help fill those gaps. Some of the examples of these would be things like Gabby's Sphere Professional Database, the EcoInvent database, the USA LCI database put together by NREL. These are just exactly what they are. They are databases of different processes that help us track the inputs and outputs. For example, if we're looking for something if we know someone's using a cold rolled steel coil, we don't need to go to that steel supplier and ask for data, because we can be able to pull an LCI database for a cold rolled steel coil, which is an average of all the US steel manufacturers that produce a cold rolled steel. So once we have the scope and we've identified all the impacts and the inputs and outputs of the LCA, and we fill all of those gaps with all secondary data that we don't have, then we actually want to run the model. And what that will do is that it will take everything and combine it into one inventory, one life cycle inventory, which will give us all the inputs and outputs of that technosphere of the model, the entire system that we're looking at. And once we have this life cycle inventory, then we want to transform that into an impact assessment. And what that does, it takes all of those inputs, all of those LCI inputs and outputs, and then weights them into impact categories. Very common impact categories would be things like global warming potential, which we've talked about, which is your embodied carbon. The carbon is going in the atmosphere. Eutrophication potential, acidification potential, ozone depletion potential, a handful of different environmental impacts that's quantifying into one equivalent of carbon dioxide, of sulfur dioxide, one equivalent that we can basically group everything together into. There's multiple ways to do this. If you are familiar, these are methods such as CML, Recipe, Tracy 2.1. All these are different methodologies to quantify the impact assessments, which are the main takeaways. And at any point of this process, we can go back. We can go circling through. If we go goal to assessment down to an LCI, we can go back up the goal and assessment. And that's where LCAs are living, breathing model, where if we're going into the goal and scope, like, well, that doesn't really make sense anymore. We want something a little bit different. So we're going to change that, go back, change the scope, which will then change the inventory. And this is all iterative all throughout here. And as you can see on the right, there's a big box for interpretation. And interpretation should be happening at every step of the way around here. Does this make sense? Do all these numbers make sense? Does this graph, should this really be 90% of the impact of the entire process? Does that seem right? And if so, great. If not, maybe we should take a step back into the inventory, see where that's coming from, what can we change there, to really understand and model this process. And these 4 boxes on the right here, the goal and scope, inventory analysis, impact assessment, interpretation, are all the 4 key pieces of an LCA. First, you have to identify the goal and the scope. You then need to set up an inventory of the life cycle, and then you want to turn that inventory into an inventory assessment, and at every step of the way, interpretation. You cannot have an LCA unless all 4 of these criteria are met, and you're interpreting the results at every step of the way. So that's kind of the basics of an LCA. What is it? Why might you do one? Some nitty gritty into kind of a high level. Why do we do it? So I want to hand it off to Frank now to kind of talk about why 6K approached us to conduct an LCA on their new technology.
Yeah, thanks, Brad. Good morning, everybody. As Pete mentioned, my name's Frank Roberts. I'm the president of 6KAdditive. So before we kind of get into why we decided to go down this endeavor of the LCA, a little bit about 6K and 6KAdditive. So we are currently 120 employees, or 140 employees, I guess now, strong and growing rapidly across 3 business units that include both the energy division and the additive, which I represent. We've raised well over 130 million to date. And we're currently sitting at 5 facilities in North America with over 120,000 square feet under roof. Currently here at Additive, we've got 200 metric tons of annual powder capacity for additive manufacturing. And so a little bit about what's next for us is this is a little overview of the campus here just outside of Pittsburgh, PA. We have a 45-acre campus. We're on the verge of an expansion, and this LCA that we just completed with Brad and his team is really starting to help frame the next version and some significant decision making in how we expand. So taking some of the results directly from the LCA and it's shaping how we're thinking about our next phase of expansion. So we currently have 2 reactors online, 2 additional coming online here in early Q2, and a groundbreaking set to start in Q3. So some exciting things on the horizon. So really, what's unique about 6K is that we focus on sourcing materials from a variety of waste streams that come from both subtractive and additive manufacturing routes. And our core IP is really creating an engineered feedstock that is the right volume that then can be spheroidized in our Unimelt technology to produce highly spherical parts or powders that then can be printed very effectively into parts. And so to date, we've demonstrated this over a wide variety of materials. The LCA that we commenced with Brad and the team at Foresight, it really focuses on titanium and nickel-based alloys. Those are the 2 predominant alloys we're manufacturing to date. We'll expand this as we go throughout the year, and as we bring on new alloys, we'll start the process all over again. Now that Brad's an expert, we expect it'll be much more efficient. So what this does is this really enables us to create some unique partnerships because we're working with customers not only as a potential sale of materials, but also a potential supplier. So we can really engage and create a circular economy. What makes it all possible? So this is, you're looking at an overview of the Unimelt technology. So each reactor is capable of up to 100 metric tons of powder per year. It operates at 6,000 degrees Kelvin. It is microwave-based plasma, the only microwave-based plasma in production of this sort in the world. It is 99% efficient. That is the coupling of the microwave power to plasma generation. It's modular, it's scalable, and provides us some unique opportunities to spheridize a wide variety of materials from low melting point metals like aluminum all the way up to high melting point materials like tungsten. We're going to tee up a poll question here and basically looking to see, are you getting the most value from your additive materials, your waste used powders, out of spec parts, your failed builds, those types of things. So we'll tee up a poll question, and hopefully you're able to answer. And if you're not getting the most out of those parts, you need to be reaching out. The team here's got some really nice programs to offer you a premium for those materials and work together to create to turn them into highly spherical powders again. So why an LCA for 6K? So there's been a lot of greenwashing over the years through various industries, and so our view is this has really become a must-have. If you want to back up those claims of being a sustainable manufacturer, this is where you start. This is how you quantify and really put some numbers behind what you're doing. So for us, it was kind of the first stop with an ultimate goal of carbon neutrality. We approached Brad and the team and talked about what's the first step in achieving that goal, and it's quantifying the results. As Brad mentioned, you're quantifying your current method and taking a look at what the energy usage and carbon generation is of your current processes. So this was the first step. This is why we started down this path. And so how did we do it? So we contracted with Foresight to essentially initiate 2 LCAs, one for our nickel-based alloys and one for our titanium-based alloys. And so this process took place over about 6 months. It is a thorough process, as you kind of garnered from Brad's commentary a little while ago. Brad will become an expert in your process. There is no way around it. That's how he's going to be effective in quantifying the environmental impacts of your manufacturing method. In doing this, what we did was we not only essentially commenced an LCA for our production methods, we also did it for traditional atomization technologies and then compared the two. And so when doing this, we were able to demonstrate pretty significant reductions, more than I anticipated, to be completely honest, in both carbon emission and energy consumption. And so I'll tease out a little bit of the results. Brad's going to dive into this much deeper next, but just for nickel-based alloys alone, we saw a 91% reduction in energy use and a 92% reduction in carbon emissions, just for the production on our nickel-based alloys alone. As I mentioned, Brad will dive much deeper into that next. He's the expert. I am just the guy along for the ride. So where's 6K in the sustainability roadmap? What we've done so far is we've demonstrated we have the ability to take in a significant amount of feedstock from a variety of sources. That can be things like turnings and used powder and failed builds and parts that are coming out of service. And we've demonstrated this ability to bring it in, create a engineered feedstock that we can then turn into premium powders from these sustainable sources. We've engaged the marketplace and we've demonstrated an ability to handle not only used powder but parts and customer specific scraps, to then turn that back, offer customers credits towards virgin powder that then they'll repurchase back. And so now what's next for us is we've got to continue to expand. We've obviously, I mentioned, we've got a major expansion coming later this year for our Pittsburgh location. What's next is to expand the footprint further and look to deploy the technology in the EU and in Asia. And what that enables us to do is it puts us much closer to the point of the scrap generation, which is our feedstock. And it also puts us closer to the end user. As Brad mentioned, every little bit of transport matters. And if you're trying to minimize the overall environmental impact, you got to be close to the source and you got to be close to the customer. This is just an example of some of the input materials and what those engineered feedstocks or waste streams look like before and after the Unimelt technology. So, there's an example of we're taking a byproduct from the water atomization process and spheroidizing it. The nickel material you see there, that's 718 that originated as turnings. That is the engineered feedstock that injected into the plasma turns into perfectly spherical powders. And you see an example on the right. That is an HDH feedstock where we've taken scrap from the aerospace titanium industry and created an HDH input material to ultimately create perfectly spherical powder. So we've demonstrated this ability to do this not only for nickel and tie, but stainless, now coppers, and a wide range of refractory metals. So continuing to expand as we add more alloys, we'll continue to benchmark and perform an LCA on each individual kind of alloy group, and ultimately chase the goal of carbon neutrality. So a little bit about why we went on this endeavor. I'll kick it back to Brad, and he can dive into the results.
Thanks, Frank. So as Frank kind of outlined, they have this new technology they wanted to quantify the environmental impacts for and directly compare it to some more traditional methods of powder production. So the scope and goal of the LCA we did for them was a cradle to end user scope with a goal of comparing their quantifying and comparing their new technology. As I mentioned before, we did not incorporate the use or the end of life phase in this LCA, since we assumed that once the powder was produced and sent to the end user, it was identical to any other source. So everything from there on would be identical. Here is the overall, with this, we did 5 total models, 3 for titanium, 6K's Unimelt, traditional plasma anodization and traditional IGA method, as well as a nickel, we did Unimelt and then a traditional gas anodization process. This was the overall flow that we identified for the LCA that we had. Starting from the top left up there, that top left tree is the titanium extraction, processing, and feedstock preparation. And then also there is a recycled titanium feedstock for any process that would use a recycled source. Next to that would be the same thing, but for nickel with the nickel recycled source. And then on the right is any packaging, which gets incorporated further down in the process. These 2 trees, the nickel and titanium, are considered in this case the cradle to gate of this LCA. This is the raw material extraction, refining, making it so whatever methodology was, whatever method was being used to create the powder, the feedstock was usable outside of this stage. And then from there, we sent it to the actual powder production, where we actually modeled the Unimelts, the gas, plasma, and IGA, all independently, using the same methodology based on primary data provided from industry experts. Anything in the yellow boxes are boxes that we changed, that we had direct control over. These are where we identified the major controllables in this model. As we changed variables in there, all the flows into them changed. So if we put more virgin feedstock, we had more virgin titanium coming down that tree, more recycled, more, and so on and so forth. So we directly controlled those 3. Everything else stayed the same, just the flows into it changed as well. So as Frank showed earlier, they showed great. The nickel was a great reduction from the traditional gas anodization process. We just showed global warming potential and energy usage. Here are other impact categories, all of which show that same trend of greatly reducing the environmental impact. For titanium, we see the exact same trend, just a little less of a drastic change. Instead of a 90% reduction, we're seeing closer to high 70s and 80%. But it's still a significant reduction across the board for all impact categories. Here you can see IGA, which is in every case was the most impactful. The plasma anodization was second, was close in most cases, and then the Unimelt is significantly lower across everything else. The issue with this process was that the titanium powder had to do a secondary, the recycled powder had to do a secondary process, which increased the overall impact. And one thing Frank mentioned was that they're really focusing on using a recycled feed stream or diverting a waste stream and making it into another product. Typically in LCAs, the cradle to gate scope consists of a very high percentage of the overall impact, anywhere from 60 to 80% of the overall impact. In this case, that wasn't as pronounced because the gate to gate process of these are all very high energy intensive processes, but it could still be a significant amount of impact percentage. So in order to get a more direct comparison, we actually isolated the gate to gate boundary. So we looked at it independently of feedstock, assuming that if everything had the same feedstock and made powder from it, what those actual processes look like in comparison. So on the top, we have the full cradle to end user energy and global warming potential numbers, which are the exact same as we showed in the last 2 slides. And then at the bottom, we have it isolated from gate to gate. So as you can see for titanium, titanium actually performed better in the gate to gate boundary, which means the Unimelt process is actually more efficient within that boundary than it is on the entirety of the cradle to end user. And again, that comes from a lot of the high energy recycling or the higher energy recycling processes that Unimelt has to do. So even though on the whole cradle to end user, it is still significantly less impactful, on isolated gate to gate, everything with the same feedstock, Unimelt actually has a more significant decrease. Nickel, although again it's still better, is still less impactful, actually increasing the gate to gate boundary. That's due to the fact that it didn't have the higher cradle to gate processing that needed to be done. Although in the gate to gate, it is still significantly at 72% less than the traditional methods for nickel. So because with these two ideas in mind, and as I mentioned before, it can't be an LCA without interpretation. We have the interpretation of the results, and we identified a few main takeaways to why the Unimelt process performs significantly better. As Frank mentioned, first of all, they're using a recycled feedstock. No matter what that full impact is from the cradle to end, the cradle to gate stage of production, if you can use a recycled feedstock, you're almost always going to use less energy and produce less carbon from the extraction and refining of virgin material. So the fact that that is an option, they can actually use 100% of a recyclable feedstock in any case will reduce their overall impact. The second one is that their actual gate-to-gate process is a much more controllable and less intensive process, right? Instead of actually using gas or plasma or using a gas to actually atomize the metal, their process is a less chaotic, less intense, and actually just more allows it to form. So because of that, it uses less energy, it uses much less gas flow rate, and therefore the entire gate-to-gate boundary is significantly better. So once we couple those two main takeaways of a recycled feedstock and a more controllable, less intensive gate-to-gate process, those two add together and compound into significant reductions in the total carbon and energy, and as you can see in all the other impact categories that we studied. One thing we did find when we were looking through this and doing a sensitivity analysis was that a key factor that we saw almost consistent throughout all the models was we could directly tie each model's gas flow rate to throughput for each gate-to-gate boundary almost directly to their entire impact. So because 6K in comparison has a very low gas to through rate ratio compared to the other processes, it identified directly to the same reductions that we saw in that ratio to the overall impact categories. And as Frank mentioned before, for nickel, we saw on a full cradle to end user, 92% reduction on carbon, 91% reduction in energy, and then titanium, we saw at minimum 78% on carbon and 74% on energy. So I'd like to thank you all on behalf of both myself, the Foresight team, and the 6K team. If any of this sparked any inspiration or any questions in you around not just LCAs, but any of your ESG questions or your sustainability journey, please reach out to us and we'll be happy to help. And with that, I think we hand it back off to Peter for some Q&A.
Yeah, so we've had some audience questions come in all along, and I'm gonna pause just a moment to let anybody who has a question and hasn't quite asked it yet, feel free to type it into that Q&A interface at the right of the screen. Frank, I wonder if I could just ask about a little more about the thinking that went into requesting this LCA. There was a slide earlier, and there was a bullet that said how sustainability and environmental goals have gone from a nice to have to a must, and I can really attest to that. It is striking to. I've been covering manufacturing for a long time, and that change is apparent that companies putting in place additive manufacturing processes are putting in place these forward-looking processes that have forward-looking objectives for the environmental impacts. And sometimes that's because of corporate mandates, sometimes that's because of the expectation of greater regulation to come. And clearly you're seeing all that too. So I guess I wonder, at some point, manufacturers are asked to or asking you to validate the environmental effects, cradle to grave, as you've said. Are you doing this analysis preemptively, expecting to get asked those kind of questions, or are you starting to see those kind of requests from customers already?
So I'll say yes and yes. It's a good question. You know, we've been in the business of recycling and upcycling for the legacy company for 30 years now, and so you know, I always say we were green before it was cool, and so up until recently, it's been, you know, when you tell people that your primary raw materials coming from a sustainable source, it's scrap that would otherwise have to be landfilled. Historically, the answer was great, but what's the price? And so over the last couple of years, that's changing. So you know, really the endeavor, and so this all stems from a conversation that I had with Bruce Bradshaw, our CMO. We had a conversation about, you know, the ultimate goal of really wanting to achieve carbon neutrality, and so, you know, this was the preemptive, you know, okay, well, what does that take? You know, how do we get a level of understanding? And Brad started guiding us through the process. So it was really a bit of a preemptive, like, you know, we know we have a sustainable process. You know, it's coming from these scrap streams. This is our culture here. We are a use everything kind of company, and so as we started down the path, and you know, really started to focus in on, with Brad's help, you know, what's important to this LCA, how can we use this as a tool, and then, you know, we engaged the sales team all along the process. The interesting thing was, once we started to tease out a little bit with customers, both current customers, existing customers, and potential new customers, they really started to latch on, and it went from a tool that we were just going to use to understand kind of where we are and where we're going in our, you know, environmental responsibility, and then it became a tool that we quickly realized could be leveraged in engaging the marketplace. And so now it's a common question coming from the marketplace. You know, what, you know, how are you being responsible? You know, your ESG, but then, you know, let's see some real data to back that up. So getting a lot of pull here lately with those requests.
There was a moment where you mentioned that to some extent, the findings of the LCA are shaping or influencing the way you're thinking about expansion and future plans. I just wonder were there any findings of the LCA that were surprising to you, or that changed your thinking to any extent?
It's the little things. So, you know, we have really strong IP, and we have a really unique technology. So the efficiency of the Unimelt is the core of the entire thing. But I did not, going into this, I did not think the little things, transportation, and you know, when you start to think about the impact of transportation and some of our, how it impacts little things like, you know, well, you have industrial gases, and those industrial gases have to get to you in some way, shape, or form, and it takes fuel to get those gases delivered. And so, you know, as we kind of grow and we're looking at our next expansion, there are certain gases that we can generate on site much more efficiently, and so that's all now, you know, weighing into the next phase of what will be the 6KAdditive. And I did not, going into this, think that those little things would have such a significant impact in kind of our overall thinking.
Well, Frank and Brad, we have a nice set of audience questions queued up. So I'm gonna start now relaying to you some questions directly from audience members. First one. We are AS 9100D certified and see that you are pursuing or have just attained this certification as well. And the question goes on to ask about stainless, which you mentioned. It says, do you have recycled 316 or 17.4 materials that meet aero requirements? And how would we set up a program to recycle our supports, failed builds, etc.?
Yeah, so good question. We are not currently AS 9100. We are pursuing. We will be by the end of the year. We're in the gap assessment phase as we speak. But we do have 316, 17.4 materials that would meet aero requirements. And the team is well versed here at setting up those programs. We've got with Eric Bono, our VP of Sales for the powder division. He's got a great team that can come in and work with you, and he'll pull in our VP of supply chain, who's got decades of experience of setting up these programs for a wide range of size of customers, from the small little mom and pop shops to managing programs like TMX for Boeing. So I would encourage you to reach out to the sales team here at 6K, Eric and his team, and definitely can set up a program to recycle supports, used powder, failed builds. We'll do a full evaluation and help guide you through the process.
Next question. Are you able to say when and where the EU-based plant will be?
I am not able to say when and where. We don't have a firm time or place yet. We are just now starting the evaluation of where that facility will be, and the timing is kind of largely dependent on our next phase of EU launch. We'll actually have salespeople on the ground in the EU starting here late next month. So that launch will dictate kind of the timing of that facility. So nothing 100% firm yet, but it's on the radar for most likely within the next couple of years.
Next question. Within the LCA, is cleaning of the recycled feedstock prior to the atomization considered?
Yes. For any recycled feedstock, any additional processing that needed to be done in order for it to be a usable feedstock was considered.
Next question. Frank, how do you control powder size distribution, and what size ranges do you produce?
So size ranges, you kind of run the gambit. It's all of the, we can do, laser powder bed, 15 to 45, 15 to 53, and then all the way up until to the E-beam cuts. We can do some finer as well. So we control PSD. It depends on the alloy, but we have some proprietary technology where we're able to kind of skew the particle size plus or minus, depending on what the customer is specifically looking for. But we do have, depending on kind of if it's a nickel-based stainless, it goes through one set of proprietary technology. If it's titanium and some of the other reactives, it goes through a slightly different. So probably can't talk a lot about that, the specific IP, but we do have the ability to cater PSD.
Another question, I think, related to what the LCA looked at. It asks, for plasma atomization and for the gas atomization, was recycling of the atomizing gas considered?
No, it was not. We did not have full data on some of the recycled rates for some of them. So we made a decision to not include any recycle for any of the models considered.
Yeah, so also excluded for the Unimelt process as well.
Yep.
So to level set,
Okay.
it was excluded for all of them.
This question's very simple, but I think we get what he's getting at. The question asks, is the price different? I think he's asking, is there a premium paid for this sustainable process?
There is not. Sustainability in our mind does not have to mean more expensive. Yeah, it is not. It is definitely not more expensive in some cases, depending on how we engage the customer and our ability to give a customer credit for their waste streams. We're able to somewhat offset and make it cheaper.
This one's kind of a hypothetical. We'll see how you guys field this. It says, if the gas atomization or plasma atomization could use 100% recycled feedstock, how much sustainability benefit would we see from 6K's Unimelt process?
Yeah, so we actually looked at this in the study, and that's where we isolated the gate-to-gate process, where that was completely independent of feedstock. So whether it was 100% recycled, 100% virgin, we just threw that out the window and just looked at, no matter what, once it came into the facility, what does it look like? And we found that through here on the lower table here on the right, the gate-to-gate shows that the results for that. So independent of feedstock, nickel Unimelt would produce 72% less carbon and 84% on the tie side.
This question says, the question asks, how's the demand for sustainable AM powders in North America? So I guess maybe Frank, speak to that big picture, like maybe in what portion of your conversations with customers is sustainability an important topic?
I'll say it's increasing. It's no secret that the EU, I feel, is quite a bit ahead of North America in terms of this ESG responsibility. But North America is definitely a trend that's continuing upward. We're getting these requests now, not only from our EU customers, but from our North American customers. It's still, I would say, not quite at the pace that the EU is sitting, but it's certainly increasing. And then, I see the comment there, are they willing to pay a premium price? I would say probably not. And to caveat that, we're not asking them to.
Brad, question to you. What other companies have you done an LCA with for powders or additive manufacturing?
6K is the first we've done for additive manufacturing.
Okay. Another question. How do companies take this data from an LCA and transfer that into carbon credits?
An LCA is a great way to quantify the carbon in your product, and people use an LCA to actually have used an LCA to claim a carbon negative product before. I believe it was the first carbon negative office chair. Is they did an LCA to quantify the carbon, and then they bought carbon offsets to make their product have a negative carbon footprint. However, a lot of times as long as you can quantify the carbon, right, then you know the entire impact for a product for a year of manufacturing, and then based on the price of carbon offsets or just the price of carbon in general, you at least have a number that that you can translate forward. Additionally, if a customer is asking, right, because they want to know, for most part, in this case, 6K is in somebody's cradle to gate scope, right? Because 6K is just selling this powder to whoever wants to make whatever they want out of it, right? So if that company were to do want to do an LCA, right, then 6K has a number for their cradle to gate to provide them. So that would take back everything down to the production of this powder to hand off. So they actually have an account of the carbon needed to create that powder that their customer could just take and then plug into and then look at their gate to gate on top of that.
We're getting multiple questions about aluminum. So I'll try to merge them. But are aluminum alloys processed? Is there any technical reason, any technical challenge to that? And with regard to aluminum, what would you expect for the LCA?
So we do aluminum, but only at small scale right now. We have proven methods to do a couple of different alloys so far. It is part of our roadmap, and one of the alloys that you'll see in marketing materials talked about probably a little bit later this year. So able to do it. There's no technical limitations as far as the impact on how we would compare to traditional, atomization technologies. I would expect to see some similar type results. Hard for me to really comment, as I'm sure we've conveyed. There's a lot of detail that goes into assessing these, and benchmarking the results and the various technologies. So I'm not an expert in atomization of aluminum, but I would anticipate to see pretty similar results because there's not really a significant change in our inputs. There's still very low, actually quite a bit lower energy required, and quite a bit lower gas flows when we're producing aluminum. So I would expect to see pretty significant reduction in environmental impact versus typical atomization.
There are a couple of questions that ask not about comparison of different powder making processes, but about comparisons of powder-based additive versus traditional manufacturing methods. So is there anything you can say out of the LCA about how metal printing compares with traditional manufacturing, such as machining of billet or bar stock?
No, the most we could say out of the study we did was more so just the production of the powder versus the billet. So we could only quantify in this case, right, the cradle to gate scope of both those feedstocks.
Yeah, to add a little bit of color to that, in probably the coming weeks, you'll see an announcement that we'll be working with a partner to do just that. So the goal is to build on the work that Brad and his team did here with the powder LCA, and we'll be working with a partner on the downstream printing of a specific part and the essential full life cycle. So all of this data will be combined to look at the full life cycle of creation of the powder and then ultimate printing of a part, and the environmental impact of that, and how that could potentially compare to subtractive manufacturing. So look for an announcement coming out at some point soon on some of that work that's coming.
Here's an audience member with kind of a long question that I'm going to paraphrase, but it starts with "Thank you for a great presentation." So appreciate that. But the question has to do with, Are there plans to take this LCA information and use it to help manufacturers make design decisions up front with sustainability as one of the considerations? In other words, choosing processes between additive, how much additive is used, the design of the part with sustainability in mind. Is there an extent to which you can help customers using this information?
I think so. I think the answer is definitely, and this is where I think the study that we're about to embark on, the start to finish, from powder to part, will weigh in and help potential customers make some better decisions about their design and the impact of their design. I think there's also a lot of ways that we can help the customers think about when they're creating a part, how much they're reusing the powder, what byproducts are generated as part of that process. How do we make sure that they don't go in the dirt? Those types of things. Condensate is always something that seems to be coming up more and more lately, and that's something for some of these hazardous materials that end up. Oftentimes it does go in the dirt, and we can help minimize that environmental impact. We have proven methods to bring that material back in. It won't go into. It's not clean enough to necessarily go into our powder process, but we have a whole alloy division that's dedicated to upcycling those types of materials and get them into alloy additions going into other metals. So definitely looking to leverage the studies, this LCA, the one we're about to embark on that will include the part, and some of our other capabilities to help customers make better decisions.
We are at the top of the hour, but I think we'll go past it a little bit and take just a couple more questions. Here's one that's kind of straightforward. Thank you for sharing the results of your study. Do you have the results of these published for further reading, or can someone contact you for these results for academic use?
Absolutely willing to share. Please, don't hesitate. Reach out, and we'll make them available for sharing and others' use. No problem at all.
Very good, very straightforward question. Can you recycle condensate?
Yeah, so as I mentioned, we can. We have the ability to bring condensate in. It will not go back into powders from sustainable sources. We have an alloy division where we create alloys, the alloy additions that will go into other metals industries for melt applications. So we've demonstrated the ability to do this for titanium. We've done it now for some aluminum, and we've done it for a host of nickel and stainless condensates. So definitely able to recycle all of those materials.
I think we'll make this one the last question. How do you quantify cleanliness or compliance with desired chemical composition of the input material?
So it's a good question. It's probably the most often asked. We've got a pretty extensive team here on the quality side of things. And anything that comes into this factory, if it's not already an aerospace quality revert stream, it has to go through some pretty significant vetting before it even passes the first gate of being considered for a powder that can go this route, or an input material that can go this route. So there's a laundry list of specifications that it must meet. There's a whole list of checks that are done for elemental chemistry, contamination, the form factor, subsequent processes it'll need to go through. But we have an entire process, ISO certified process, that we put everything that comes through the factory through to make sure that it is absolutely in the right form factor, it's the right cleanliness, it's contamination free before it would ever be considered an input material for a powder.
All right. Fascinating topic. That takes us a little bit past the hour we promised. Clearly a lot of audience interest in this, but we'll conclude it there. I want to thank our presenters, Brad Van Valkenburg of Foresight Management and Frank Roberts of 6K Additive. Learn more at 6kinc.com. An email with a link to a recording of this webinar should come to you soon. Thank you for your time today. I'm Pete Zielinski with Additive Manufacturing Media.